and they go, show that y equal to, I'll write this out, a times e to the r sub 1 of x plus b times e to the r sub 2x is a solution to, you don't have to do this now, this equation. 2y double prime plus y prime minus y equals 0. I'm just curious, what would you do? They got the word show. So this wasn't a find the values. If they want you to show this, what we have to put here. Get the second derivative of this, right? No, these are just constants. That r sub 1 would just be a constant, and r sub 2 is a constant. That a and b are constants, and they just want you to show that this would come out that the left-hand side would equal the right-hand side, which is just a what? 0. All right. Hey, one more we're going to do from section 9.1. Then we'll come back to that. How do we get that integral that we looked at before? So before we go back to this, we're going to come back to this. I had that earlier. Rate of change of population is proportional to the size of the population. We'll come up with an integral for that and how to attack it. But I want to make sure we do a problem like number 9 because that could leave you hanging when you look at the problems in this section over the weekend. So this is what they have. Here's the differential equation. It is rate of change of a population with respect to time. They have it equal to 1.2 times p, and they got a 1 minus p over 4,200. And they just asked some questions about this differential equation. So this is a differential equation. I'm going to correct it. Here's the first question. What values of p is the population increasing? For what values of p is the population increasing? How would you approach that? That's why I wanted to work with this problem with you today. I wanted to work it with you because you understand taking derivatives and stuff. But this problem is just like, what are we going to look at? And when this is rate of change of population, right? For population to be increasing, the rate of change would have to be what? Positive. There you go. So that's what we're looking at. When we attack this letter A, when is the rate of change positive? Right? That means positive growth. So when is the rate of change? So to solve this, we're looking to see when is dp dt greater than 0. So it really comes down to this, doesn't it? Because when population p, you can think of people. It's always going to be positive. It's always going to be positive. So our focus is right here. This is our math problem. If we're trying to see when dp dt is greater than 0, then I'll say dp dt is greater than 0 when this right here is greater than 0. And I'll step away so everyone can see this. This becomes our math problem. It's not a calculus problem. I know it's calculus when we're talking about the rate of change. We don't need calculus to solve this. It's an inequality, though. We've got to solve that inequality and figure out what it is. Some of you might just logically figure out what the population size is, so that this here is always greater than 0. I bet you can figure it out, but when is this right here always greater than 0? Why did I ignore this part? I ignored this because population is always going to be greater than 0. So I only need to concentrate on that. Hey, I'm going to get some common denominators here. What would this be? 4,200 over 4,200 minus p over 4,200. Okay, so 4,200 minus p all over 4,200. Will that work? So this is an inequality. We're going to look for what's called the critical point. The critical point is a population value that makes that numerator equal 0. That's going to help us get our answer. 4,200. So there's our critical value. Have you ever solved, this is called a rational inequality. Sometimes you may have come to a pre-calculus course, a college algebra course, and the instructor went, I'm going to ignore that section. So you might be sitting there right now and never seen this before. This is called a rational inequality. We've got to solve the rational inequality.
Isn't there a property that when you divide by negative, you flip the...
That's right. But p is an unknown right now, but you're right. But right now, you know what we do to figure this out? We found the critical point. The only critical point for this found in 4,200, we got to pick a test point.
Could just be anything like under 4,200?
You got it. So let's pick a test point. We're just going to see if this is true when this is true. So what's the number lower than 4,200? Do you want to use 0? You know, or we can just, how about just like 1? 4,200 minus 1 over 4,200. Is that greater than 0?
Yes.
What do y'all think? It is. But everyone, what if you use a number higher than 4,200? Like, I don't know, 10,000.
Then you have a number greater than 1, and when you subtract it from 1, it becomes negative.
So if I use a population, so my test point over here, this comes out negative, right? Which would make the statement false. But if I use any number between 0 and 4,200, this comes out as a what? True statement. There's my answer. And I'm going to put this. How about interval notation? And I'll put a box around it. There you go. It's the interval 0 to 4,200. You don't have to write this in interval notation. If you want to put it in, you could say what? When the population is greater than 0, but less than 4,200. You can write it like that too.
So basically all real values between 0 and 4,200.
You got it. Now letter B, I know you're going to know the answer, everyone. Same question. For what values of p is the population decreasing? So I'll put it right here, Owen. Can you figure out the values of p where the population is decreasing? What values of p is the population decreasing? Well, we got it right there. When p is greater than what?
Supposed to be greater than 0. Can you have
Yep.
a negative p value?
We can have a 0, we can't have a negative p-value for these problems, everyone. I want to point that out. These populations, whether it's bacteria or people, it's always going to be, it can be 0, right? Some can go extinct, it could be 0, but it won't be negative. So you can assume that for all these problems here in terms of a population. Population would be positive, but now, what are the values of p decreasing? We got it right there. That's when this would be what?
4,200 to infinity?
There you got it. I'll just go like that. It goes 4,200 to infinity. You can write it like that. If you put it in interval notation, it would be what? 4,200 and beyond. But see, a lot of you all are thinking about real populations in this world. Sometimes what happens, there's like a this capacity level, right? And they call it the carrying capacity, where something will just increases very rapidly at the beginning. Think of fish in a lake. But due to the limited size, it starts to what? Level off. There's like a carrying capacity. So, but let's leave it like that. Just say 4,200 and higher. Now, when there is a letter C, I'll put it right here. I don't know if you've ever heard this word. The question, what are the equilibrium solutions? Oh, what are the equilibrium solutions? Question mark. You go, what's the equilibrium solutions? The equilibrium solutions is where dP dt, the differential equation, is equal to 0. So let me say again, so you have it in your notes. What are equilibrium? Equilibrium solutions are the solutions such that that differential equation, dP dt, or whatever we have, is equal to 0. So when does dP dt equal 0? I think there's two answers. When is dP dt equal 0? There's two values of p where this happens.
When p equals 4,200.
When p equals 4,200, there's another answer.
When p equals 0.
When p equals 0. And as we said earlier, p can be negative, right? So this is it. Those are the equilibrium solutions. Equilibrium solutions, when's that rate of change equal 0? That's what they want you to get out of 9.1. Just an introduction, understand what these words are, understand that, oh man, these are just differential equations. There could be one solution, maybe there's more, but it does involve integration to see what their solutions are. Sometimes it's hard to integrate, so we use like slope fields. We won't get in that today, to get an idea what's going on with all this. So, and now it's time. Can we return to this? Here it is again. The rate of change of a population with respect to time is proportional to, when I say is proportional to, I'm using a constant K, the size of the population. We can assume that. Is that always true? It's true with some populations. And it could be bacteria, where the rate of change of the population is proportional to the size population. Proportional to the size population. The question is, can you find the solution? So, where does this get taught? And by the solution, I'm talking about P. I'm talking about P, the actual P equals. And there could be more than one, right? There could be a family of solutions. Because with integrals, don't we get a plus C? A plus constant? There you go. Okay. So find a solution. Here, we can think of it as P. All right. So in your notes, I want you to put down 9.3. This is titled Using Separable Equations. Using separable equations. That one's separable, S-E-P-A-R-A-B-L-E. To solve differential equations. Now we know why Calculus 2 is a prerequisite to taking a differential equations course, right? To know this technique. And when the reason we need separable equations is because, do you notice there's a P on this side and a P on this side? The technique is rather simple. Get all the P's on the left, get all the T's on the right. Integrate both sides with respect to the variables. Don't forget, we're going to have to put plus constants, right? And then solve for what left? P. That's the technique, okay? So what's step one? Step one is really important. We got to separate these, all right? Separable equations, we got to separate. Let's get all P's on the left and T's on the right. Hey, if this was Y's and X's, I always get Y's on the left-hand side and X's on the right-hand side. Can you help me separate this? dP over dt, I can divide the P, right? And then take the K and multiply the dt on both sides? The most important step. I hope you find the rest not too challenging. Is that what I do there? And now we're going to integrate this side with respect to what letter? P. And we're going to integrate this side with respect to T. Hey, can you always find integrals, or excuse me, before I say it, can we always separate equations? I want to go over here to the side real quick. What if you had this? dP dx. No, I use y. I mean, can you always separate equations? Sometimes it's impossible. And we'll look at that right there. Can you separate x's and y's? And it's impossible. So sometimes it's impossible. So I just want to point out, it's like, oh, this is cool. Guess this will work every time. Not with every differential equation, you follow me? But with many differential equations, we can use separable equations to do it. All right, you ready to integrate? We're going to integrate the left and integrate the right. Let's integrate the left. Integral the left with respect to p. What's the integral of 1 over p? We're going to stick an integral on this. Natural log of p. What's the integral of k, a constant, with respect to t? kt. So natural log of p, I have to put the absolute value first. And then kt, and we have to put the plus constants, right? So if I do a plus constant over here and a plus constant over there, can I just put one plus constant on the right? True. Let me say it again. You're like, where's the plus c over here? Well, I have a plus constant over here. I have a plus constant over there. We can collect them and just call it 1 plus what? Because it's in some unknown constant. Does that make sense? Am I okay with that?
I'm a little stuck on the integral of d, because I'm seeing dp over p, I'm thinking I can factor out p over p, which would be 1.
Oh, how about, think of it like this. 1 over p, and that dp is just the, I gotta use a capital P. That's just like the dx we always have.
Oh.
Think of that as like 1 over x dx. And write it like that, everyone. So just if that was confusing to you, that's not only Armando, that happens to a lot of students. They gotta know what to do with this. And you go, oh, that's that. And you go, oh, I know what that is. That's natural log of x. So I encourage you actually maybe to write it like that in your notes. And when I just do the plus c, now we're getting close. The rest just involves some type of algebraic manipulation. What do I gotta get out of this? A p. The only problem is it's got a what? An ln in the front. Can we use z? And we got an equation, balanced equation, do whatever you do to the left, let's do it to the right. What's e to the ln of p? Just p. Yeah, so if you never knew that, e to the ln of x is just equal to x. Right? E to the ln of t is just equal to t. E to the ln of p is just p. So I'm going to raise e to the ln of p equals e to the kt plus c. I got to shrink the kt plus c. It's up in the exponent though, right? Cool.
Does it matter where you put the plus c? Like, does it have to be?
I always put it on the right. I encourage you to do the same. Because mathematically, you're right. Kind of like, it's just going to be a plus constant throughout this whole equation here. We can combine them, but it's always, I think it's beneficial we just write it on the right every time. Now, when I'm going to write this another way. Did you know like x to the 2 plus 3 can be written as x squared, x cubed? So let's rewrite this as e to the kt times e to a constant. We'll leave this left right here. Oh, why do I keep writing like this? So what's e to the ln of p? I wrote it over there, I might as well just, I can keep writing it, but e to the ln of p is just a p. The bars are still there, but we're going to take those bars off in a second because we got this what? This unknown constant. Plus or minus, so we can just take those bars off in a second. Was everyone okay with what I did there? That sometimes can stump someone. I want to show this is the property of exponents. X to the 2 plus 3 is x squared, x cubed, where that base stays the same. I kept the base the same. So when I'm going to take off those absolute value bars now, you go, why? This constant right here could be, you know, a positive or a negative, right? Some plus or negative values. I can take that off. E to a constant, can I just call that a constant C? What is E? 2.71828, right? E is 2. So 2.718 raised to a constant is just a unknown constant. So I'm going to call this letter C and put it in front of this. And we solved it. Now, I hope this looks familiar to you. Did you see equations like this in a pre-calculus course? A lot. Or money investment. Investment of money.
Yeah.
This is like the initial amount,
Yeah.
right? You probably saw it written like this in your pre-calc. They wrote like initial P, E to some rate. They might use R or K.
Like a continuous interest.
That's right. And you had no idea that the rate of change of that what? Whatever that population was, that was money. With respect to time was proportional to the population size. Isn't that cool? So this is called separable equations. All right. Great job with that. We can't solve for C now, right? That's because this is a family of solutions for different values of C. C could be what? Maybe 10. C could be 100. C could be 1,000,000. C could be 5. We have a family of solutions to the differential equation. But I do want to point out, you go, are there any others? No, because we did it by separable equations. Cool. Let's try another one. One before I erase. Sometimes they do give you an initial value. If they give you an initial value, you can find C. You know, they're like this. Here's an initial value problem. If they give you something like this. Oh, the initial value. When P equals 0, that's the initial value, the population was 1,000. Well, can you now find C? When you're all said and done, what would C have to be? So I'll put what? 1,000 This would be to help us find C. C, e to the, what would go here? What's k times 0? K is just some constant. 0, what's e to the 0? 1, what's the c value? 1,000. So if this was given to us, if we had an initial value, that's all we need. What's going on at time equals 0? Oh, then the equation becomes p equal to 1,000 e to the kt. But if they don't give you an initial value in the problems in 9.3, then you just have to leave your answer in terms of a constant. Cool. They used to have separable equations on the Calc 1 exam. Did you have it? I'm just curious. In the last one. On the AP, you took an AP exam, everyone, but they didn't have it. They used to have it on the AB exam. Separable equations. They removed it, moved it to the BC exam.
If we get a question like that, well, I'm guessing you're not going to put a question on the test where time is 0 and the initial value is given to you.
Sometimes what they'll do is the initial value is going to be, it doesn't have to be at t equals 0,
Okay.
but they will give like, if they gave you like
I'm
some
just
initial
saying,
value.
like, it just kind of follows that if it's t is 0 and you have an
Oh,
initial
yeah,
value,
exactly.
then it's
But they'll write something like this, like they'll say p of 0 equals 1,000.
right.
That's what they'll write. So they have a very good question. They'll say something like this. Hey, here's your initial value. And they'll give you this, and they want you in the end, just, you gotta wait till the end to substitute though, true?
Yeah.
Cool. So, and I'm gonna give you one of those. Let me erase all this. Great job with that. So if you ever see this written, know that this just turns into that nice little C times e to the kt formula. Has anyone ever heard of Newton's law of cooling? If you have, we can do the same thing with Newton's law of cooling. It talks about the rate of change of being an item, like you pull something out of like the freezer or the fridge, and it starts, you know, well that would be heating. But if you take something you put it inside the refrigerator, it starts to cool, right? Newton's law of cooling applies. But you can solve it by doing separable equations. And this problem, let's try this. dy dt is equal to negative 4y minus 32. And David, I'm going to put a semicolon right next to it, provide the initial value. Y of 0 equals 20. And when can you find the solution, which would be like, find what y equals. Using separable equations. So we'll use separable equations to figure out what y is. Okay. What's the first step? It's the most important step.
dy dt plus 32 divided by 4.
So you got it. Separate them. Get all the y's on the left and get the what? dt's on the right. Okay? But where do I put this thing? Armando, I heard you. You're saying just divide it? That would work. This is me when you don't have to follow my advice, but I encourage you to do this. I try to leave as much as I can up on this right-hand side with that dt. So I'm looking, can I factor something out of that before I divide? I mean, absolutely right, Armando is right. I mean, I could have gone like this, but I'm going to erase this. I'm going to try to leave more stuff up here with the dt. You could have done this, but the challenge is, do you know how to integrate this? It involves an natural log, but you got to be careful. You got to use a u sub. I just want to avoid the u sub, unless you love u subs, right? So here's what I'm saying. My advice. I'm like, well, let me, before I go separate, what can I factor out of that?
-4.
If I factor out a -4, I can just let it leave it and hang on the right-hand side with the dt. And now what's left over here?
Y plus 8.
That's my advice. My advice to you, I'm like, I will leave any constant I can up here with the dt on the right-hand side. And if it's negative, you bet, I'll leave that negative there. I just think it makes the integral on that left-hand side a lot easier. But I know, I'm looking at your faces. People are like, oh, I could integrate that. You know how to do u subs. And you would have been fine. Armando, you would have been totally fine. I know you know how to do the substitution rule. I'm just trying to avoid a u sub. So when I'm now going to separate, I get dy over the y plus 8 equals -4 dt. And I'm ready. It's time to integrate. What's the integral of this?
ln of y plus 8.
Bless you. Kate, very good. What's the integral of -4 dt? and then we'll put a plus constant. All right. This is natural log of 0, and I didn't have to do a u sub. That's my point. But you could have. You'd get the same answer. It's totally fine. If I can avoid a u sub or integration by parts or something, I will. Now, I'm in that same dilemma. I'm trying to get y. So look at it carefully. You got to think. You're now in pre-calculus mode. How do you get just y out of that? What do you do to both sides? E to the left and e to the right, right? E to the ln of y plus 8 will just turn into what? Y plus 8. Don't forget you got to e to the right though. And I make this really small. Make that really small there. Okay, what's the left now? Oh. Y plus 8. I'm going to take the bars off, okay? Do you know another way to write this?
C times e to the negative 14.
You just did 2 steps at once, and I'm going to do it. Let me just check if the class is okay with that. He just did 2. He says that's c times e to the negative 4t. Is everyone okay with that? That's e to the negative 4t times e to the c, and e to the c is just a big old what? C. You bet. So I think we got it, except we got to subtract the what? There it is. Now on your next test, just before you turn in your piece of paper, here, I ace this. Check it over. Did I answer the question?
No.
Because this had the what? They gave me the initial value. If they give me the initial value, okay, then we can find that constant. And by the way, the same thing happens with Newton's law of cooling. It's just like I put something in that refrigerator. I'm like, all right, what happened after 10 minutes? How cold did it get? That's all I would need as initial value. I can figure out what's going on. In this case, everyone, let's figure this out. Where do I put the 20? We're now trying to solve for C.
Equals to the y.
Here, 20. Big old C. E to the negative 4 times 0 minus 8. What's e to a 0?
1.
I think we know what C is. Add an 8 on both sides. C is.
28.
So my final answer. Y equals 28. E to the
Negative 14.
negative 4t minus 8. Hey, does anybody, I'm just going to extend this question. What would happen to this expression as t goes towards infinity? What would happen to this as t goes towards infinity? Remember, that would be e to the negative infinity, which is 1 over e to the infinity, which would approach a 0. So 0 minus 8. As t approaches infinity, this would approach a what? A negative 8. Cool. Awesome. Hey, last problem. So here, do this, everyone. This is from 9.3. Okay. Nothing crazy here. Last one. dy over dx equals x over y. Y of 0 equals negative.
Are you purposely trying to make it look deceptively simple and it's going to come out to a thing half a board?
Wait, say again?
Are you purposely making it look like it's something deceptively simple? And we're
That
gonna
does
end up
look
with-
simple. But you know what? The reason I chose this problem, I go for the problems, Armando, where I get most due questions from students. But you're right, it does look like, hey, this is going to be too bad. Because he knows to separate this, what do you get? Y times dy in. Right? But I get a lot of questions on this. So that's why I wanted to do it. What's the integral then?
Y squared over 2.
Nice. How about that?
Y squared over 2.
So Mondo, you were correct. It looks rather easy. That wasn't hard integrals. And I integrated this and I integrated, I didn't even put the integral symbols down, right? Isn't that what's going to happen? So I really skipped this step, but the challenge is I got to solve for what? why? And I think that's where the problem comes in, where students get a little struggle. They struggle a little bit with this. Not everyone, but I get a lot of questions on this. So how would you solve for why? What would you do? It's a great idea. I mean, it's just multiply 2 on this side. All right. 2c. Sounds good. What happened to these 2's?
Cancel. 2C can be written as C, right?
2c can be written as c. And if that confuses everyone, I could write plus k. I'll just make it the letter. I'll go over here, everyone. K equals 2c. Because I'm with you. He's right, though. 2 times some unknown constant, you can just call it what? Constant. So last step, Armando, what would y equal?
Square root
You
y
nailed
equals
it.
square root of x squared plus k.
So why do I get a lot of questions on this? Something's right here. What'd you do to both sides? You took the square root. What do I have to put there?
Plus minus.
There you go. Now we got to figure out for our solution. Here's the initial value. Which one are we using? Are we using the positive or are we using the negative? Let's go find out. So where am I going to put that?
Should be the negative because you can't get a negative.
He already knows. He goes, it's going to be the negative. He already spotted, so very good. Negative 3 equals either a plus or a minus the square root of 0, whoops, yeah, that's right. 0 squared plus a constant. What would be the constant? You know? K would have to be a 9, but square root's got to be positive, right? So when he's saying K has to be equal to 9 for this to be true, right? But this must be the what? He says for the plus or minus, it must be the minus 1 because this is negative. Does that make sense? So the final answer, you go, what is the answer to this problem? Here it is. We're not going to put the plus, we're going to put the minus. Y of t is equal to negative square root of x squared plus, you can use k or 2 times c. I just used k. What was k? 2c, which is this 9. And when I'm going to check it, is this right? You put a 0 in here. Is 0... Wait, this was an x, right? Y of x, I'm a y of x. Or just put y. Y of x, can't you just put y? I don't want that y of x to bug anybody. But you can check it. Does that point work? But notice I didn't do the plus or minus. Hey, in terms of these problems, I'll make sure even next week, if you have questions, we can do a couple more of those too. All right? But we did get up to 9.3. Have a great weekend. Great job. Hey, Armando.